A particle p moves with acceleration. A is 16 cos 4t, 8 sine 2t meters per second squared. Given that the particle starts from rest at 2, 0, find the acceleration when t is pi seconds, the velocity when t is pi by 2 seconds, the displacement when t is pi by 4 seconds. A second particle q starts at the origin at t equals 0 and has velocity 2 over pi, 8t over pi meters per second. Show that the particles collide when t is pi seconds. So in part A, we already have acceleration. We just need to substitute t equals pi in. So that's going to be 16 cos 4 pi, 8 sine 2 pi, and we should know that the cosine of 4 pi is 1 and the sine of 2 pi is 0. So that just gives us 16 meters per second squared. Now in part B we need velocity, and that means that we need to integrate. So if we integrate, cos goes to sine, so we'll end up with 16 sine 4t, but then we need to differentiate by the inside function, which is 4, which is why we get 4 sine 4t. And don't forget we need a constant there. Sine integrates to negative cos, and then we need to divide by the inside function differentiated. So divide by 2, and that's why the 8 there has become 4. So it's negative 4 cos 2t plus a second constant. Now we know that it starts from rest. So 0, 0 is going to be 4 sine 0 plus c1, negative 4 cos 0 plus c2. Of course, sine of 0 is 0, and cos of 0 is 1. So that tells me that c1 is equal to 0, and c2 is equal to 4. So the velocity is going to be 4 sine 4t, and 4 take away 4 cos 2t once we put the constants back in. Now we're interested in when t is pi by 2, so that becomes 4 sine 2 pi, and 4 take away 4 cos pi. Sine of 2 pi is 0, cos of pi is negative 1, so what we have here is 4 plus 4, so that's going to give us 0.8 meters per second. So in part C, we want displacement, so we need to integrate velocity again. Remember, the velocity is here. So sine is going to integrate to negative cos, and cos integrates to sine. So we're going to have negative cos 4t. Remember, we divide by the 4, and that's where this 4 has gone. We need another constant, of course. And 4 would become 4t. Cos has gone to sine, and we needed to differentiate the 2t and divide by that. Remember, that's the reverse chain rule, and that's why this 4 has become 2. We know that r is 2, 0 when t is 0. So 2, 0 is going to be equal to negative cos 0 plus c3, and 0 is going to be 4, 0, take away 2 sine 0 plus c4. And of course, sine of 0 we know is 0. So that gives me that c3 is 3, because what we've got here is negative 1. So negative 1 plus c3 equals 2. So we need, c3. We need c3 to be 3. And c4, of course, is 0. And so r is going to be equal to this. So r of pi by 4, we're going to substitute in, gives us 3 take away cos pi, and then 4 over pi by 4 times pi by 4, take away 2 sine pi by 2. Cos of pi, of course, is negative 1, sine of pi by 2 is 1. So what we have there, 4 times pi by 4 is, of course, just pi. The 4's cancel. And so we have 4 and pi minus 2. Now, in part D, we have r is 3 minus cos 4t and 4t minus 2 sine 2t. r of pi is going to be 3 minus cos 4 pi and 4 pi minus 2 sine 2 pi. Cos of 4 pi, of course, is 1. Sine of 2 pi, of course, is 0. And so we're at 2 4 pi. Now remember, we were wanting to show that this second particle is going to collide with the first particle when t is pi. So in other words, what we need to do is show the second particle arrives at this point. So for q, we know the velocity was 2 over pi, 8t over pi. So integrating that gives us 2 over pi t plus, I've called this constant 5, and then integrating this we get 4t squared over pi plus constant 6. And we know that that particle started at the origin, and if you substitute in that r is 0, 0 and t is 0, you'll find that both of those constants are 0. So in other words, r is 2 over pi t and 4t squared over pi. So r of pi is going to be 2 over pi pi and 4 pi squared over pi, which is 2 over 4 pi. So we can see that they are at the same coordinates at the same time, and therefore they will collide.